This is Mr. Long again, and I'm going to take you through a few stoichiometry problems, and we're going to have a stoichiometry roadmap. Now, I am certainly going to recommend viewing one or two of the Khan Academy videos at the beginning to introduce stoichiometry. And stoichiometry can be, but first off, let me just say that I want you guys to take notes on all the videos that I'm doing from now on. I want it to be just like in the classroom. Because I know like when you're watching lots of videos, it's hard to take exact notes. But if you guys recall from when I was teaching you in class, I do like for you to take very good notes. And at the end of the note-taking session, you can send them to me on your phone via attachment through Remind or through the school email. But anyway, stoichiometry, and that's a really big word there, is used to express the quantitative, which is numbers, the quantitative relationship, I left that out, relationship between reactants and products in a balanced chemical equation. So it's all about the numbers, and you got to have a balanced chemical equation. Now I'm going to go faster than you can write at this point, so you may certainly pause the video and take notes, better notes. You can do that at any time on any of the videos that I make. Now the roadmap, and I think you guys have seen their roadmap before, it's very important when it comes to solving stoichiometry problems. And the best way to do it is to memorize it. Now it looks really complicated, but it's not. The way that you start with this is that you start with the mass of a substance, which we call mass A. And you can use a periodic table to convert that back and forth to moles of that substance or moles of A. And then when you have a balanced chemical equation, those numbers in front of the compounds and elements, those are the mole ratios or the molar ratios or the coefficient ratios. So CR means coefficient ratio, stands for that. So you can convert from moles of one substance to moles of another substance, which we call moles B. And then you can use the periodic table again to use the mass of that substance in the periodic table to convert to mass of B. This is what I call the central road in the roadmap. So you start with that and memorize that. Now, this is really a mirror image of itself. One side is A, the other side is B. So if you get one side down, you automatically have the other side. So moles is sort of like the central station. And if you go there, you can go anywhere. You can calculate how much volume of a gas you have at standard temperature and pressure. Now, and I can show you that down here, standard temperature is 0 degrees Celsius. Standard pressure is either 1 atmosphere or 760 torr or 760 millimeters of mercury or 101.3 kilopascals or kPa. That's what STP stands for. So let's zoom in just a little bit. Okay. Now, anyway, you can go from moles to volume using a magic number, which is what I call it, of exactly 22.4 liters of any substance in 1 mole of that substance. And you also can go down south here using Avogadro's number, 6.02 times 10 to the 23rd power. You have this many number of particles in 1 mole of anything. It could be a mole of bricks, a mole of students. It could be elements. It could be molecules. It could be formula units. It could be really almost anything. And this is also a magic number. You'd be doing well to memorize both of these. So what I really want you to do is memorize one half of this roadmap eventually. Start with the central road here, and then get your volume and particles down, and know that B is just a mirror image of A. Okay, it will help you in solving these stoichiometry problems. So there you go. And we have already solved for simple problems, like mass and mole problems. Let's do let me bring this back down here, a mass A to moles A problem. And let's say we have 88 grams of CO2, and we want to convert to moles. It'll be put to you in a question form, but I like to put it straight as it is. Now, I'm thinking that when you use a periodic table, for our purposes, we have been rounding either to the 10th or to the 100th, but let's make it easy on ourselves. Let's just round to the whole number. Okay, and so that'll make our life a whole lot easier. So when you're going from moles A to mass A to moles A, you're going to use the periodic table. Look at the molar mass. Okay, so when you have this, you start, whatever you're given, you start with that. So 88 grams of CO2. Now some people just draw the lines. I don't like that. And you can have another step and another step. But I like to just draw the T's here in the framework. So whatever we have in the top of the first step, that unit has to be in bottom of this next step, so this can cancel out. So the units can cancel out. So we're going to have grams of CO2 on the bottom. And I'd like for you to put units first. And we're going to go to moles of CO2. And by mole will always be the number 1. In 1 mole of CO2, we'll have such and such. So you go to the periodic table. Carbon is equal to 12 times 1, which is equal to 12. This will look familiar to you. Oxygen is equal to 16, and we got 2 is equal to 32. Add them up and you get 44. This came from the periodic table, PT. So we're going to put that 44 right here by grams of CO2. We're going to cancel our units out like this. And so I want you to pull your numbers over. 88, the ones will drop out, over 44, and we're in moles of CO2. And just like in any good math problem, I want you to reduce. So of course this is equal to 2 moles of CO2. Go ahead and put a nice little rectangle around your answer like that. And you've seen this type of problem work before. That's a one-step problem. It's one step. And the reverse. Okay, if you were doing the reverse, let's say we're doing moles A, and we're going back to mass of A, and we use a periodic table either way that you go. And let's say that we have 36 grams of water. I'm sorry, take that back. Let's say we have 2 moles of H2O. Okay, we want to know what the mass is. So we'll have 2 moles of H2O, and in 1 mole of H2O, we're going to have so many grams of water. So what we're going to do is we're going to go to the periodic table again. Hydrogen is equal to 1, and we have 2 atoms here is equal to 2. And oxygen is equal to 16 times 1 is equal to 16. So we have a molar mass of 18. Put 18 up here. Okay, the moles cancel out. 2 times 18 is equal to 36 grams of water. So that's easy. Okay, and we're on to our next step. So I'll stop it here and we'll go on to the next step.